can't drive that car. Shut your...
You may be wondering, what is this device that Derek is using? Well, I, along with my other presenter, Derek, will explain the ins and outs of the seatbelt. First, some background information. My name is Nicholas Atkins, aka the Better Nick. My favorite class is math, my hobbies are sports and video games, and in the future, I'm going to be a lawyer.
And my name is Derek Kamei, aka the IRL Paint Beast. My favorite class right now is engineering. One hobby I have is playing basketball, and in the future I would like to become an architect.
Now that you know who is speaking to you, we will give some background information about the seatbelt. This seatbelt was manufactured by Mercedes. We got it from a little box of seatbelts that Mr. Gasca provided for us. We have found the seatbelt going for about $250 American. We picked this item because we wanted to challenge ourselves, not go the easy route like Colin Emerson, who traded it out for the easy route.
From the first glance of the main seatbelt body, we can see that it is very bulky and square-like. There are multiple shapes incorporated into the actual design with many triangles, squares, and circles. Multiple parts have great spacing so that each component can move smoothly. The colors beige, gray, and black are predominantly used in this design.
The function of the seatbelt is to keep you safe during sudden stops of your vehicle. The seatbelt reduces your chance of dying from car accidents substantially. If the vehicle is moving at high speeds and suddenly comes to a stop, the metal ball inside of the mechanism rolls forward and causes the turnstile to stop being able to turn, which locks the roller into a carefully designed wedge, which prevents the seatbelt from extending any further, which prevents the user from flying forward out the windshield or into the seat in front of them. We had to defer the ball rolling thing because we couldn't actually see the ball until we opened it up. The hypothesis we arrived at before tearing it up was about the same concept, except we didn't know about the ball and thought it was just the gears.
For our disassembly process, I started off with the plastic part that covered the gears. I pressed a pencil into a small hole and enabled it to be taken off. Inside we found gears, circular discs, and springs. On the other side of the seatbelt was another plastic cover. We had to saw it off and use a screwdriver to wedge it out. Inside was a massive bronze metal coil that popped out. One difficulty we encountered when disassembling our product was when we had to saw half of the frame to help unlock the rest of the seatbelt. As of now, all the parts we discovered were the green spiral thing, white spiral thing, metal ball, light blue box, orange arrow, black peg leg, double white gear, single white gear, rainbow metal circle, bronze metal coil, the plastic covers for the gears and coil, a small white circle, and the seatbelt frame. After disassembling the seatbelt, we individually measured each part and put it into a chart. Some special parts I'd like to talk about are the metal ball, black peg leg thing, white spiral thing, double white gear, single white gear, green spiral thing, and the seatbelt frame. I want to talk about this because when the car suddenly stops, the metal ball presses into the black peg leg and stops the movement of the white spiral thing. Since the white spiral thing is connected to the gears stop along with it. This causes a chain reaction all the way up to the main seatbelt frame, which stops the movement of the axle.
We started the modeling process by creating a folder to put it in and sharing it to Derek. Then we sectioned off who built which pieces and started to build them one by one in their own separate files. We did this because we needed to be able to make a drawing file for each piece of the seatbelt. It was just a lot easier to do it this way. The challenges we faced is that we had a ton of pieces that were small and very detailed. We overcame these challenges by taking our time and looking up how to do things we didn't know how to do. In one of the pieces there was a slanted side, which I didn't know how to do, so I had to improvise, and I used the chamfer tool, which made the slope needed.
Some challenges I faced while doing the drawings was finding the right angle to display them. Some parts were at a slight angle and I couldn't really display it correctly. I fixed this by finding the best angle possible. The most difficult part about the seatbelt assembly on Fusion was finding out where each part went. I fixed this by reviewing with my partner.
Things that would change about the design is making it easier to take apart / dissect for people who are doing something similar to this or want to know how the seatbelt works without having to ruin the seatbelt permanently. The way I would do that is I would make the bolts screwable so they can be removed and put back easily.
Personally, if I were able to improve on the design of the seatbelt, I would use much cheaper yet durable materials. I would do this by substituting current materials with other materials that are cheaper but are able to do the same job. If you look back to its original design, we can see multiple different materials being used, such as steel and plastic. Another improvement I would probably add is not having the overall shape end up bulky and cube-like. We can see in its current design that it takes up a lot of space. I can fix this by giving the seatbelt a design that doesn't take up too much space, for example, like a sphere. We can also, just like what Nick said, make it easier to dismantle. We can do this by using screws and bolts to make it more accessible for people to dismantle. What I enjoyed about this reverse engineering project as a whole was sawing through the seatbelt frame because it was cool. And if I were to improve this project, I would have chosen a much easier thing to disassemble.
If we were to redo this project, Derek wouldn't be gone so many days, so we could have gone a little faster and done things better. And if we were to redo this as our final, we probably would have chosen the wind-up toy because it's a lot easier and actually can be done in 2 hours.
Thank you for listening to our presentation about the seatbelt. I hope you enjoyed and were well informed.